Dear students, under the lecture series on the topic sequencing problems, here we have the third problem under type 1, that is n jobs in 2 machines. The question is to find the sequence that minimizes the total elapsed time required to complete the following tasks on machine 1 and machine 2 in the order M1, M2. Also find the total elapsed time and the ideal time of machine 1 and machine 2. So these are the tasks given, that is the jobs. And machine 1 and machine 2 and its processing times are given here with respect to the jobs. Now here if we observe, we have 9 jobs over here. First step is to find the order of the jobs in which it has to be performed. So we have to find the job sequence first. For that we have to draw 9 blocks in order to order the jobs. So we have drawn the 9 blocks over here, and we know that on the left we have to write the first mission, that is mission 1, and to the right we have to write the next mission, that is mission 2. So now we shall observe what is the minimum value of all these processing times. So if we check out, 2 is the least value, that is the minimum value of all the processing times that we have here. What is the job corresponding to it? It is job A, and this 2 is under which mission? M1. So job A has to be written under mission M1. So here we have mission 1. So job A has to be written here. After writing this, we can just give a strike for this so that we know this is completed. Next, we have to look out for the next least out of all these processing times. So if we check out, we see that 3 is the least element. But we see that there are 2 3s appearing in this. That is, we have a 3 for job E and a 3 for job G under the same mission M2. So now we will have a confusion whether to write E here or G here, because under mission 2 we have to write on the right. So we should know which we have to write, that is E or G. If this 3 has appeared in 2 different missions, then one job we would have written here and the other we will write in mission 2, and so there will be no tie. Now since they have appeared in the same mission, we have a tie. So for that, the procedure of Johnson's algorithm, which is used to solve the sequencing problem, says that we have to look out for the minimum value from the other mission. Now we know that the tie is for these 2 3, which is in mission 2. What you have to do is you have to look out for the corresponding value in M1 for this 3. What is the value? It is 6 over here. And what is the corresponding value for this 3? It is 7. Out of these two values, which is minimum? You have to check. So we see that this 6 is minimum. Therefore, job E has to be chosen. So E has to be written under mission 2, because the tie is in mission 2 only. So E has to be written under mission 2 first. Now job E is over. So once it is over, just give a strike. And next the tie was with this 3, and that is for job G. So obviously G has to be next written here in mission 2. And after writing G here, we have to give a strike so that we know that it is completed. Now of the remaining processing time, so if you see, these are the remaining processing times. Of these values, which is the minimum, we have to look out. So if we see, we have 4 as the minimum, but we observe that there are 3 4, that is, we have a 4 here, here we have a 4, and here also we have a 4. So there is a tie between 3 4s. So we should know which 4 we have to select. Now if you see, these 2 4s have appeared in mission 1, and this 4 has appeared in mission 2. So this 4 has independently occurred in another mission. So there is no tie for this 4. The tie is only between this 4 and this 4, since they both have appeared in the same mission. So now first we will sort out this single one. Now since this has appeared separately, this 4 has appeared in mission 2, and it is the job is corresponding job is D. So D has to be written under mission 2. So there is no tie in that. So directly we can write D over here. So this job is done. So D is completed. Now the tie is between this 4 and this 4 which has appeared in the same mission, M1. What did I tell you? If the tie is in the same mission, we should look out for the corresponding value of this 4 from the other mission. So what is that? 7. And what is the corresponding value for this 4 from the other mission? It is 11. So out of these two, which is minimum? 7 is the minimum. Then we have to choose this 4 only. So after choosing this 4 is for job C, which is under mission 1. So job C has to be written under mission 1. And after completing that, just give a strike for it. And then we have this 4. And the job is I. And this has appeared in mission 1. So we have to write here. That is, job I has to be written after C. So after writing, we can just strike it out. Now next, what are the remaining jobs left out? I mean B, this is left out. D, this all is completed. F is left out. H is left out. So when we see what is the minimum value of the remaining values, here we have 5, 8, 8, 9, 5, 8. So which is the minimum? 5 is the minimum. So this 5 and this 5, we have 2, 5. Again we have a tie because they have appeared in the same mission. So since the tie is in the same mission, what did I tell you? We have to look out for the corresponding value in the other mission. Here what we have? 8. Here what we have? 8 again. So if it is same, if it is not same, then we have to choose the minimum. But if it is same, then we can choose arbitrarily. Any one you can choose. So either you can choose B first and then H, or you can choose H first and then B. And now since these two 5 which are in tie is from mission 1, we have to write to the left. So that is, we have to write here the job. So either you can write B first or H first. Since the corresponding value also you couldn't find the minimum, you can arbitrarily choose. So what I am going to choose is B. I am going to choose here, and then I am going to choose H. But it is up to you. You can also choose it in this way. You can write H here and you can write B here. That is an alternative sequence for this sequence. If you do that sequence also, your answer will be correct. So after that, so this is completed now. B is completed, H is completed. So the remaining job left out is F only, and so we have to write that F over here. And so therefore the job sequence for this problem is A, C, I, B, H, F, D, G, E. Or it can also be, if you change this, the job sequence can also be A, C, I, this H and B, because few can choose like this also. But anyway, the answer will be correct. Either this can be the job sequence or this can be the job sequence. So you have two job sequence for this, which will definitely give you the same answer. So I am going to proceed the problem with this sequence. So I have drawn the tabular column over here, required tabular column, which I have explained about this tabular column in our previous video lectures. So kindly go through it first and then look into this problem. So here we have to write the jobs in the order that we have found, that is the sequence. In this sequence we have to write the jobs. So it is A, C, I. So that we will write here. It is A and then C, and after that I, and then we have B, H, F. So B, H, F, and then we have D, G, E. So D, G and E. So we have to write the job in the sequence that we have found. Now we have to write the processing time for mission 1 corresponding to these jobs. So if you see, these are the processing times. Okay, so these are the processing times in mission 1. For example, for A, what is the processing time? It is 2. So we have to write, here we have to write under processing time, we have to write 2 here. So this is 2. So for C, what is the processing time? It is 4. So that we have to write here 4. For I, what is the processing time? 4. So again that you have to write here. And for B, what is the processing time? It is 5. So that you write here. For H, it is 5. So we are looking into mission 1. Okay. So this is 5. For H, it is 5. For F, it is 8. For D, it is 9. And the one is for G, it is 7. For G, it is 7. And the last one is E, which we have as 6. You can also do this problem without writing the processing time here. Every time looking into that given tabular column and adding it. But for convenience, I have divided the tabular column in this form. Yes, and then for machine 2 also we have to do the same. For A, what is the processing time in machine 2? It is 6. So take and write that 6 here. And for C, it is 7. And then we have I, the processing time is 11. So like this we can fill this column. And in order not to confuse, after writing all the processing times, I have drawn the horizontal lines also in order to distinct between the jobs. Now always remember, when the first job enters mission 1, the time in will be 0. And after processing for 2 hours, that is we have to add here. So 0 plus 2 is time out will be 2. So this 2, because after A finishes only C enters, and it will enter after this 2 hours. So this 2, or else you just remember this 2 has to be written here. So 2 plus 4, so which is 6, and then this 6 has to be written here. So 6 plus this 4, which is 10, and then this 10 will come here. So 10 plus 5, which is 15, then 15 has to be written here. So 15 plus 5 will be 20, and then this 20 will be coming here. So 20 plus 8 will be 28, and then you will have this 28 over here, plus 9 will give you 37, and then this 37 has to be written here, plus 7, which will give you 44, and then 44 will be coming here, plus 6 will give you 50. So we are done with the time in and time out for mission 1. And for mission 2, always remember what is the time out for job A in mission 1, 2. So that has to be written here. So 2. Now again the same process. So 2 plus the processing time. So here it will be 8. But one thing is, you have to, next while writing here, you have to check whether 8 is maximum or 6 is maximum. Which is the highest? 8 is the highest. So that you have to write here. So 8 plus 7, which will give us 15. Again the same we have to do. So either 15 is greater or 10 is greater. Which is greater? That has to come here. The maximum is 15. So write that 15 here. So 15 plus 11. So that will give us 26. So we have to check 26 is greater or 15 is greater. 26 is the greater one. So we have to write 26 here. And so 26 plus 8, which will be 34. So 34 is greater or 20 is greater? 34 is greater. So 34 plus 8, that will give us 42. So 42 here we have, and here we have 28. Which is greater? 42 is the greater one. So 42 plus 9, and that will give us 51. So this is 51 is maximum or 37? 51 is the greater one, that is maximum. So 51 plus 4, that is 55. 55 is greater or 44 is greater? Definitely 55. So 55 plus 3, which will give us 58. Obviously 58 is greater than 50. So 58 you will have here, and 58 plus 3 gives us 61. So this 61 is known as the total elapsed time. So this gives us the total elapsed time. So we shall take and write that. So we have taken and written. Next we have to calculate the ideal time for mission 1 and the ideal time for mission 2. In order to calculate that, we should first add all the processing time for mission 1. So if you add 2 plus 4 plus 4 plus 5 plus 5 plus 8 plus 9 plus 7 plus 6, you get the total processing time as 50. In a similar manner, you should add all the processing time for mission 2. So 6 plus 7 plus 11 plus 8 plus 8 plus 9 plus 4 plus 3 plus 3, and that is 59. So we have added up all the processing time in order to calculate the ideal time. So ideal time of mission 1 we have to write, and the formula is total elapsed time minus the processing time of mission 1. So what is the total processing time of mission 1? Here we have, this is the sum, this sum. So this is the total processing time of mission 1, which is 50. So therefore this is equal to, total elapsed time is 61. So 61 minus 50, which is equal to 11 hours. In a similar manner, we have to do for M2. That is, the ideal time of M2 is equal to total elapsed time minus processing time of M2. Total elapsed time is 61 minus what is the total processing time of M2? It is 59, which we have calculated here. So that is 59. So what is 61 minus 59? It is 2 hours. So therefore, mission 2 remains idle for 2 hours. Mission 1 remains idle for 11 hours, and the total elapsed time is 61 hours. Hence, we are done with the problem. And so therefore, always check out for the units given in the problem. Here it has been not given, so I'll just add here, so in hours. So if it is not given, you can just write units. Okay, now because I have taken hours here, the answer will be in hours. So I have written in hours, but if it is not given, you can write 61 time units. So that also you can do, but you have to mention it as time units. Okay. So with this problem, we are completing our problems on type 1. We have done 3 problems under this. So if you go through those 3 problems, it will be definitely sufficient to understand type 1. Next, we will move on to type 2, that is n jobs on 3 machines. So our concern will be about this type in our next video lecture. So kindly follow the lecture and understand type 2. Thank you.